We'll proceed in various coordinate system and we will see interoperability, hybrid model or alloying. Calculus, you are amazing, you are awesome. Various coordinate system, you are amazing, you are awesome. Algebra, you are amazing, you are awesome. Vector, you are amazing, you are awesome. Numerical science, you are amazing, you are awesome. Then which one is not amazing and awesome? Everything is amazing and awesome. What is not amazing and awesome is that how we use them. Calculus in its layer, in its work, if we use it perfectly, it is awesome. Vector, you are awesome. Algebra, you are awesome. Numerical science, you are awesome. Coordinate systems, you are awesome. But the idea is who is using what at what time and how he is using. How he is kind of maintaining co-relationship, co-operability, interoperability between them. How it is. One way is layered approach. Generally, this is what people see. On numerical science, algebra is based. On algebra, vector is based, something like that. And then calculus is based, and then coordinate system, something like that. So, if someone really want to use what is the idea? You use various technology to get the result. How these technology are related to each other? They may be related in a layered fashion, or in some other fashion, or in some other fashion. Okay, one of the design is layered approach, where you have to understand at which layer you are sitting. Just finish that work, and then the result you pass it to lower level or something like that, or from lower to high, people also think whatever. But the net idea is you have must understand that at what level you are working. That layer you have to work as per the layers protocol, and then it is done. If you are working is coordinate system layer, then you have to think that all expressions should be well defined as far as coordinate system is concerned, and then push off. Then if you are at vector level or whatever, you see that everything for the vector perspective, everything is nice. If you come to calculus level, you do your work and push off. You come to algebraic level, you do your work and push off. So first you arrange the different layer in some fashion, and then start executing one by one. Don't think that much. People who think very, okay, you think while relating the all the components each other, how interrelationship you make. Like if you are sitting in an examination, then generally it is a good way that you do the designing first and then start the implementation. Or before designing, you understand, you do the analysis of the requirement, then you do the designing. I mean, I'm not asking you to write the answer, but when you see the question paper, then just pass through the question paper once. Take some time, again pass through the question paper once. Take some time, again pass through the question paper from bottom to top. Keep doing it for few times, 5 minutes, 10 minutes, 15 minutes, 20 minutes. Then analyze it very nicely. Okay, come to a design phase in your mind that how you would tackle which one first or something like that. So if examination is for 3 hours, then probably you can put half an hour, 45 minutes, 1 hour in requirement and collection and designing phase. Last 2 hours you can tackle. Okay, so that phase is required solving mathematics also, that what are the technology you will use, vector technology, algebra technology, numerical science technology, then coordinate system technology, which where, calculus technology, whatever. Now arrange them in some fashion. So first is analysis, then designing, then start enjoying it, start eating it. Okay, then eating is the main thing you need. Okay, now we are in a phase that we are calculating surface area of a sphere. Surface area of a sphere. I can go with the pure Cartesian coordinate. What are the coordinates that we have discussed? Cartesian coordinate, polar coordinate, a spherical coordinate, and cylindrical coordinate. So four coordinate system that we have discussed. Now if I see Cartesian coordinate, then what we have talked is that if I have a algebraic equation or if I have a function fxy, so if it is a sphere, then fxy equal to a square, that is the radius of the sphere, a square minus x square minus y square root, where fxy, that is z, is the dependent component and x and y are independent component. If that is true, then if I have a flat surface, if I have a flat surface that is xy plane, if I have a flat surface that is xy plane, then xy plane is considered as independent component in which x-axis and y-axis two independent variables are there, but full xy is considered as independent component. Based upon this xy independent component, we have fxy or z. So z equal to square root of a square minus x square minus y square is the calculus way of algebraic equation, we can say. Otherwise, the sphere equation is x square plus y square plus z square equal to a square. But in calculus way, where we have to segregate the dependent and independent, then it is fxy equal to square root of a square minus x square minus y square. Now what we saw that if I have a velocity vector along x-axis, velocity vector along y-axis, and if I do cross product of these two, then I get an area velocity vector. If I calculate the area velocity vector, because cross product will calculate area between them. If I have area velocity vector, if I get the magnitude of it, then I have area velocity. Now if I have area velocity, algebraic equation, area velocity vector to area velocity algebraic equation, if I calculate the magnitude. If I do the integration of the area velocity algebra equation on the xy plane, I get the area. Area what we get is nothing but it's again a algebraic equation. If it is algebraic equation where independent components are x and y, if I keep changing x and y, I get the area from the beginning. This is what we saw calculating the curve length earlier. If I want to get the curve, if there is a circular curve or any curve, if I want to get the length of the curve from one position is beginning position. From beginning position to any position, what is the length of the curve? Then I calculate the velocity vector. I have position vector. From position vector, I calculate the velocity vector. That is a tangent at any point. If I have velocity vector, I convert it to velocity algebra, that is magnitude of it. Now if I do integration of this algebra, then I get the curve length. That is function over x. Function over x means if I keep changing x, then from beginning I get the curve length. So here, if I have velocity vector along x-axis, velocity vector along y-axis, if I do cross product, I get area velocity vector. If I calculate magnitude, then I get area velocity algebraic equation. If I see area velocity algebraic equation, then if I integrate this with the xy plane, along the xy plane, I get the area from the beginning. As an algebraic equation, function over x and y, keep changing x and y, gives the area from the beginning. If I keep the changing x and y from beginning to other side of the sphere, then full half sphere, hemisphere, I get the area. Multiply by 2, I get the full surface area. Now, we proceeded in that. So, what is dfxy by dx? That also called fx. That is partial derivative along x-axis. What is position vector? Now, we start with the vector analysis, not the algebraic equation. what is the position vector? If I have a sphere, then any point sphere is centered at the origin. Sphere is centered at the origin. If there is a point on the surface of the sphere P, what is the position vector of the P? That is xi plus yj plus zk. Xi plus yj plus fxyk. If that is the position vector, then what is the velocity vector? One velocity vector is along x-axis, one is along y-axis. So partial derivative along x-axis is I plus dfxy by dx One is j plus dfxy by dy k. If I do cross product, then it becomes minus fy minus dfxy by dy minus fyi minus fxj plus 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 1 means plus k. If I get the calculate the magnitude, then it comes fx square plus fy square plus 1 square. Now this is the velocity area algebra. Now I have to integrate with the xy plane. Now it becomes that fx is nothing but if fxy is 1, if fxy is the square root of a square minus x square minus y square, then dfxy by dx is nothing but minus x divided by square root of a square minus x square minus y square. So this area velocity magnitude turns up into x square by square root of a, I'm sorry, that is fx square plus fy square plus 1, x square by a square minus x square minus y square plus y square by a square minus x square minus y square plus 1, a square root. That will turn up as a square divided by a square minus x square minus y square full square root. That will turn up as a by square root of a square minus x square minus y square. Okay. Now I have to integrate with the xy plane that in Cartesian coordinate converts into dx dy. dx dy. First I have to integrate this a by square root of a square minus x square minus y square with dx. Keep the limit is, now if I have a sphere, then along x-axis minus a to plus a, along y-axis minus a to plus a. These are the two integrations. Now if I integrate a by square root of a square minus x square minus y square, a I can keep outside, dx. So dx, so if I have a square 1 by a square root of a square minus x square, dx integration is sine inverse x by a. Here a square minus y square is constant. So integration would result in sine inverse of x divided by square root of a square minus y square. So now set the limit minus a to a. Okay. Now you can use, someone can use kind of angular fashion. I believe it is trigonometry or whatever it is, setting, thinking that whatever it is, this is the first integration. Sine inverse of a, first limit is a, sine inverse of a divided by square root of a square minus y square minus sine inverse of minus a divided by square root of a square minus y square. Whatever is there, now I have to integrate with dy and then limit is minus a to a, minus a to a, whatever has come. So this was given as kind of, this was given as a kind of exercise that someone has to find integration. Okay, try it. If you are not able to do, then we have other solution. Okay, we can take, I believe, y as cos x, then it will be sine inverse 1 by sine, because a by a would go away. So if I take y as a cos x, then it will result in 1 by sine a cos theta, 1 by sine theta. So sine inverse of uh, cosine, okay, cosine theta, and then y I have taken a cos theta, then that would result in a sine theta dy. So a will come out and it will come a square outside. Now sine inverse of cosine theta into sine theta d theta. Accordingly, I have to set the limit and someone can calculate whatever it is. This is how it is. Okay, what is coordinate interoperability? That comes into the picture now. Now consider what is the net integration that I have to calculate. So net integration I have to calculate is a by square root of a square minus y square minus x square dx dy or d of xy plane. Double integration d of xy plane. If I see a sphere that is centered at origin, if I cut the xy plane, it will cut it at the middle, and there are two hemispheres, one hemisphere and bottom there is another hemisphere. But xy plane is a circular region. XY plane is a circular region. If XY plane is a circular region and that is the region, that is the integration dA, then that is nothing but that can be tackled as polar coordinate, because polar coordinate talks about a region that is circular. If polar coordinate talks about a region that is circular, then what is dA? If I do integration dA xy plane, then what is dA? dA, generally people think dA is nothing but an infinitesimal small area or whatever it is. There are two ways to think about dA. One way to think about dA is you take any, if I have a circle, if I have a circle if I have a circle centered at origin, then what is the small area, that what is the independent component of the circle? Independent component of the circle is, one is radius. One is radius because radius can grow and shrink. One independent component is radius, and another is if radius moves, then there is an angle. So angle will increase without changing the radius, and radius will grow and shrink at any angle. Both are independent to each other, and with these two, the circle can be denoted, represented. If that is the case, then what is the, if I take any strip, like if I take any strip in Cartesian coordinate, that is dx dy, if I take any strip that is x length and y length, then if it is very small, I call it delta x and delta y. This is one fundamental generally people follow. So if I see that way, then I have to take a strip along both independent component, not at x and y. So one independent component is r, that is the radius. Another independent component is the arc. That's why it is area. One is r and another is arc. If you combine these two, it forms an area, two sides of the area. One is radius and another is arc. Okay, so that's how it is area. So if I have radius, then I call the small distance is delta r. If I have an arc where the angle is very small, that is delta theta, then arc it forms is r delta theta. If angle is 2 pi, then it makes arc as 2 pi r, that is the circumference. If it angle is only delta theta, then circumference is make is r delta theta. So two sides of any small area with two orthogonal component dA is r d theta dr. So now the dA, what I replaced with dx dy earlier, now I would replace with r d theta dr. Now I have integration in polar coordinate as a, okay, a by a square root of a square minus x square minus y square. Okay, so a square minus x square minus y square root, then r d theta dr. Now integration will start from 0 to a, because radius will grow from 0 to a and angle will grow 0 to 2 pi. Now let's see what is in polar coordinate, what is x axis equivalent in r. and theta. So if I have x-axis, then it is nothing but r cos theta. If it is r and it is x-axis, r cos theta, r sin theta. So y is r sin theta. If that is true, then x square plus y square equal to radius square, that is r square. So if I say r cos theta, r sin theta, it becomes r square. Same. Now I have a by square root of a square minus r square cos theta minus r square sin theta. That would result in a by square root of a square minus r square. A square minus r square. If that is true, then their integration is r d theta dr or r dr d theta. So r by a square root of a square minus r square. A numerator I can keep outside. It's a constant. So r by a square root of a square minus r square. So what is the integration for it? So if I go with antiderivative, then it is a good case that it is a square root of a square minus r square. If it is a square minus r square, then differentiation would result in minus r divided by square root of a square minus r square. So the integration would be minus square root of a square minus r square. This is what I believe. So. Now, if I place the limit is 0 to a. If it is a, then full it becomes 0. A square minus a square. If it is 0, then it becomes a. Only a. So, a is the integration. Now, d theta 0 to 2 pi. 2 pi a. 2 pi a. Okay. And a is outside, so 2 pi a square. So 2 pi a square is the surface area of a hemisphere. One section only I have taken. Minus a to a I had taken and a minus a to a. Now if I multiply by 2, then full I am getting. So that is because it is Cartesian coordinate only. Temporarily I made a hybrid model where if I know dA, a by square root of a square minus x square minus y square dA, that dA is dx dy, but that is in a spherical component, it is r d theta dr. Then the limit what I had taken minus a to a minus a to a, that is minus x to plus x minus y, but that was only for for hemisphere. So whatever we have done, it is only for hemisphere. 2 pi a square. So full spherical area is 4 pi a square. Okay, this is hybrid model. Means just see that we have used whatever we need at any time. Just convert into that. Your concept should be very clear that what are you looking for. So this is surface area that is like hemisphere, sphere, sphere, surface area. Okay, now can we go with this hybrid model if I want to calculate the surface area of a sphere where hybrid model is spherical, not polar coordinate. We talked about polar coordinate. Can we go with the hybrid model where d area is spherical coordinate? Means I am talking about the xy plane only, and in xy plane there is a circle. If there is a sphere, then xy plane cut the sphere at the center and it forms a circle. That is the dA. dA converted to dx dy as far as Cartesian coordinate is concerned. It converted to r d theta dr as far as polar coordinate is concerned. How it will get converted into spherical coordinate system, that is a big question. This is our our way. Whatever I am going to talk now, so we will place disclosure on. This is our way to calculate the surface area from the kind of perspective of spherical coordinate system as far as dA is concerned. What is dA? One is dx dy, another is r d theta dr. Okay. Now, if you see a spherical system, if I have a sphere and a sphere is centered at the origin, then there is a radius called A. If there is a radius called A, then radius A, the R would vary from 0 to the end, that is the A. A is the maximum radius that touching the sphere. If A is the maximum radius that is touching the sphere, R is a radius that is variable. What are the three independent components in a sphere, in spherical system? A spherical coordinate system is about 3D. One is radius of the sphere, not in the xy plane, radius of the sphere everywhere. Another is theta, that is in the xy plane. This is what we saw. Another is phi angle, that is from the vertical. From vertical, there is a phi angle that goes like this. And there is theta that is in xy plane that goes like this. And there is a radius r that from 0, it goes till the surface. If radius, why it is orthogonal component is, one would vary. If I make one guy vary, one, I should not use the word guy because these are very precious. If one entity is varying, then other two entity may not vary. Would not vary, will not vary. That way they are orthogonal to each other. So if I have a radius A and suppose that this is from vertical, it is making angle phi, and then it is falling from the in horizontal plane, there is a theta angle here, and if I raise it, then from vertical it is phi angle. Now if I change the radius, okay, radius length, neither phi is changing nor theta is changing, so independent. Now just think that if I have taken theta angle on the xy plane, and then radius is constant, theta angle is constant, radius is constant, but phi would change now. So phi is independent to radius and theta. Now in xy plane, the phi is 90 degree fixed, radius is fixed, but I can change theta. So three are independent components as far as a spherical coordinate system is concerned. Now our integration is a by square root of a square minus x square minus y square, where two limit is 0 is minus a to a minus a to a. One in x-axis, one in y-axis, dA, d of area, where area is dx dy in Cartesian coordinate system, or d theta dr in polar coordinate system. Then in a spherical coordinate system, what it would be? That is the question. Okay. Now in polar coordinate system, what it would be? Now let's see little more clearly what is the area. Now area is only in the xy plane. That is done. So if there is a radius A, if there is a radius A, okay, if there is a radius A and it makes angle phi, it makes angle phi, then it is A sine phi that falls on the xy plane. That is the radius. If there is a radius A fixed, touches the sphere end and makes phi angle from the vertical, then A cos phi is this component, then A sin phi that falls on the xy plane. A sin phi is smaller to A or equal, not bigger than that. Now A sin phi, okay, what we want? Actually we want r d theta dr. R d theta dr means whatever is the radius into d theta. So radius is A sin phi, A sin phi d theta, A sin phi d theta. So now r d theta convert to A sin phi d theta. What about dr? Okay. So what about dr? If r d theta converted to A sin phi, A sin phi d theta, then what about dr? What is r? In polar coordinate, this is r and this is theta. R is A sin phi. So r d theta dr is the dA in polar coordinate. Then accordingly, if I convert from a spherical coordinate, then this would result in a sine phi d theta d of r is a sine phi. So it will convert into a cos phi d phi, a cos phi d phi. Okay, and here we have a a sine phi d theta, a sine phi d theta, a cos phi d phi. Now what about x and y? Let's consider relationship between what is the spherical coordinate equation, x square plus y square plus z square equal to a square. If I keep x equal to, how they will be related to each other in theta, a and phi. Now if I say a sine phi and then it comes into a phi, a sine phi cos theta is x, a sine phi sine theta is y. So it becomes a sine theta, a sine phi cos theta square, a sine phi sine theta square. That result in a a a x square plus y square plus z square equal to a square. If I replace x and y with a sine phi cos theta and a sine phi sine theta, then it results in a square sine square phi. Theta will go. Now, if that is true, then z has to be a cos phi. It is actually a cos phi. If this is a and makes angle phi, then it is a cos phi. That is the z. So here also. So if I keep a, it should follow equation a cos phi. Now a square sine square phi plus a square cos square phi is nothing but a square. This is what it is. Now let's go and change a by square root of a square minus x square minus y square. So x is a sine phi cos theta and y is a sine phi sine theta. X square minus y square would result in minus a square sine square phi. So a by square root of a square minus a square sine square phi. That a will go away and 1 minus sine square will result in cos square phi. So 1 by cos square phi will come into the picture. I mean 1 by cos phi. On numerator side, we have a sine phi d theta, a cos phi d phi. So cos phi goes away. Now we have 2a, so a square. A square is constant, we'll keep it outside. Now sine phi d theta d phi. So sine phi d theta we have to integrate. So sine phi, if I integrate, then it results into minus cos phi. If it is minus cos phi, then phi I have to take from 0 to 2 pi. Okay, but it is hemisphere. So I believe I'll take 0 to pi by 2. That is the phi. Okay, that is the hemisphere. Now if I take like this, then sine phi cos phi d phi. Integration is cos phi. Cos phi 0 to pi by 2. Cos phi 0 to pi by 2 would result in 1 because pi by 2 cos is 0. So 1, only 1. So 1 and d phi. D phi, if I go with full 2 pi, then it will result in 2 pi. I mean d theta. So 2 pi. So 2 pi is the integration. A square I had kept outside. Now it becomes 2 pi a square. That is the hemisphere surface area into 4 pi a square. This is our calculation. Certainly we are going to file disclosure on it. So this is interoperability among the coordinate system as far as we see that it is Cartesian coordinate and polar coordinate together we come to 4 pi a square, and if I take Cartesian coordinate to spherical coordinate, it is again 4 pi a square. Now what is remaining? What is questionnaire for the today? We started with partial derivative along x-axis and y-axis to have the area velocity vector. Then we did cross product. Can we think this purely in a spherical coordinate with two velocity vector, so two velocity vector in two independent component region area. Okay, so what are the two independent component region, or in polar coordinate system or in cylindrical coordinate system? Cylindrical coordinate is extension to the polar coordinate system. Only there is one z is it. Now someone can try in cylindrical coordinate system. Take velocity vector, partial velocity vector along one independent. Here we are taking partial velocity vector as independent component x, one independent component y, dfxy by dx and dfxy by dy. Now here we have independent component. If I take r and theta as independent component and z as dependent component as far as cylindrical coordinate system is concerned, then dfr theta by dr, dfr theta by d theta. This will lead into two orthogonal velocity vectors. Try to make cross product and then get the magnitude of it and try to integrate directly. Try it in spherical coordinate system. Okay, so we took velocity vector along x-axis, velocity vector along y-axis, did a cross product, got the velocity area vector, calculated the magnitude, velocity area magnitude algebraic equation. That algebraic equation we integrated with area dx dy, and then we got the net surface area. Try to do same with the polar, cylindrical and spherical coordinate system, where partial derivative should happen along the independent component, that is r, theta, z, phi, whatever we have. Try to do cross product and then get the magnitude and try to do integration directly over there, rather than hybrid model what we have created. So that is the questionnaire that someone has to solve it. So we will move on. There is no end. We will move on and we will see that how kind of volume generation is so nice. So a surface area we talk, then we'll talk in volume area also. We'll solve questionnaire what we had given, and then we'll see either we can kind of close it or is there something that is remain.